Okay, everybody, so from where we left off, we have put the strong acid, hydrochloric acid, into the container, and we have figured out its pH through calculations of negative log. All right, so now we're going to add some sodium hydroxide, a strong base, to it, and this is a reaction that is going to go to completion. There is no equilibrium involved here. So the first thing I'm going to do is figure out the moles of each one, and you can see there under the HCl I have the liters times the molarity, and under the NaOH I also have the liters times the molarity. So I find out that of one I have 0.0025 moles, and of the other I only have 0.0024 moles. That means the NaOH is the limiting reactant, it is all used up, and the HCl is the excess reactant. So we're going to end up with 0.001 moles remaining of the HCl, and we're going to have a total of a 49 milliliter solution. That's because we add the two volumes of acid and base together. So then we have to recalculate the new molarity of the remaining HCl, moles over liters, which gives me 0.00204 molarity, or concentration, and then we plug that into pH equals negative log, and we get 2.690. And that's all because we had strong acid remaining. Okay, so now we're going to go on down to what happens at the equivalence point. So at the equivalence point, we are at equilibrium. We are at the I meant to say that should not. That is written incorrectly. That should not say equilibrium point. That should say equivalence point. That's what it should say there. And at the equivalence point, we know that the moles of the acid is equal to the moles of the base. Okay, so if that is the case, that means we don't have any H plus concentration left over. We don't have any OH concentration left over. All we have made now is water, and water is a pH of 7. If you need that confirmed for you, for water to be a pH of 7, its Kw is 1 times 10 to the negative 14. The H and the OH are equal to each other, and so they equally cancel. So we end up with water with a pH of 7. If you took a pH of this value, in other words, if you did a negative log of this value of the H right here, you'd end up with your pH of 7. Okay, so we're going to move this along now to what about if we add a little bit more NaOH? What happens now that we have started with only HCl, we add a little bit of NaOH? You might have already started noticing that the pH is going up, as it should. We're adding base to this solution. The pH should go up. So once again, we have strong acid, strong base, chemical reaction, but this time the strong acid is the limiting reactant. It is all used up. And the strong base is the excess reactant. It is left over. So we end up finding out that 0.0001 moles of NaOH remains, and the total liters is going to be, the total liters should be, oh boy, I find all kinds of mistakes here. That should not be right. Total liters, which should be 0.051. And let's see if I did my calculations correctly. If I did my calculations correctly, that should be 0.0001 divided by 0.051, which means that I should come out with 0.00196. So I'm off by a 0.0. So that means this is going to have to be changed to 0.00196. And that means my pH, or sorry, my pOH is going to come out to the negative log of 0.00196, and that gives me a pOH of 2.708. And that means my pH has to change, because I'm going to subtract now 14 minus 2.708. And when I do that, then my new pH is going to be 11.292. Boy, I can't write that. Let's try a little bit of things. There we go. 11.292. Sorry for my miscalculation of the volume there, but you see how that might get really, that's an easy mistake to make. Once again, Mrs. Shiro is still making mistakes, even if she's had time to pre-write everything. All right, so that's what it looks like when we are titrating a strong acid with a strong base. Important points. Remember, whichever one there is leftovers of is going to be the H or the OH that drives the pH. It makes sense in this one that since the base was the solution that was left over, the base should be what the pH is. That is very definitely a basic pH. It is above 7. Okay, so we're going to get rid of that and scroll down to now what happens if we use a weak acid and a strong base. So our first thing is, okay, before any strong base is acid, what happens to, what is the pH like? So if you take a look at this, same as before, the problem is this is a weak acid, so we have to do a rice table. So we knock out that rice table, and you'll notice that that follows Ka is equal to H plus times the anion concentration over HA. HA simply is the original concentration of the acid. All right, plugging all that in, we end up with a hydrogen ion concentration of 0.00134, and we end up with 2.87 for our pH. That is of our weak acid. Okay, so then what happens if we add some NaOH? Okay, so now once we have it, we are still going to have to start out with stoichiometry first. Write out your equation, and by that I mean the acid-base equation. Write out that acid-base equation. Go ahead and subtract the limiting reactant. And so what I did is I calculated moles using liters times molarity. I calculated moles, and then I subtracted the limiting reactant from the excess. So I end up with excess moles of weak acid remaining. Okay, so my molarity of my weak acid is 0.0429. Now, you might be tempted to use pH equals negative log, but this is a weak acid. We have to use a rice table. We're not allowed to use negative log at this point in time. So now we're going to go and scroll down to, yes, the good old rice table. This time our equation changed to the water dissociation of the acid, HC2H3O2 plus H2O, and so there it is. We're going to calculate using our Ka value of 1.8 times 10 to the negative 5. And so we end up with the X value of 8.79 times 10 to the negative 4. That's our hydrogen ion concentration. And now we can use that to solve for our pH. So we've added one step here because it is in fact a weak acid that remains. So the weak acid requires that we have to use Ka to solve for the hydrogen ion concentration and then use the negative log. Okay, I am going to stop my discussion of that right now. Your assignment for all of this is to have written some notes, and then you are going to have a laboratory activity that you are going to have to do online and ultimately show me. You're going to see a laboratory page from your online laboratory activity. Have a great week, everybody.